Buonasera, tutte e tutti. Good evening. I'd like to welcome you all, our guests online and here in this room from the side of Istituto Svizzero in Rome. We are very happy that you have come to listen to tonight's keynote speaker, Professor Peter Fornaro, who will talk about data science in arts and humanities. What is useful data? My name is Maria Böhmer. I'm the head of science at Istituto Svizzero, and I'd like to say only a few words on the context of this keynote, which is our collaboration with the Digital Humanities Initiative, DHCH, and the universities of Basel and Bern. And this is already the third time that we are co-organizing this event, each time with a different topic and collaborating institutional partner, but always with an important focus on the PhD students who write their thesis in the field of the digital humanities. So this afternoon, you have already had an internal workshop with PhD talks and exchange, and I'm very pleased that you are eager to connect with the Roman digital humanities landscape, not only with the public keynote of tonight, but also with tomorrow's public roundtable that will include some of the national academies and also open up to the international context to exchange over the state of the art regarding digital humanities at these institutions. So you're all warmly invited to come back and join us also tomorrow evening. Istituto Svizzero and the DHCH initiative share some common goals, namely to connect researchers and foster interdisciplinary exchange in the humanities and beyond. And this year, we are pleased to welcome the Photo Consortium as your partner for this event, which opens up to the international European context with strong links to Italy, of course. And please let me kindly invite you also to the public conference tomorrow morning on 3D in Cultural Heritage, organized by the Eureka 3D project in collaboration with University of Basel Digital Humanities Lab. And you have the possibility to follow in presence or Zoom. And finally, I'd like to thank very much the organizers, Peter Fornaro, Vera Chiquet, and the organizing board for our collaboration. And now it's my pleasure to introduce Peter Fornaro. He leads the Digital Humanities Lab at the University of Basel and is co-leading the PhD program in Digital Humanities. With a background in scientific photography and technical engineering, he received his PhD in experimental physics at the University of Basel in 2004, followed by a postdoc in digital imaging and digital preservation. Please correct me if I'm wrong. In 2018, he completed his habilitation and received the Venia Legendi in Bilddokumentation in Kunst und Kultur, always at University of Basel. His areas of expertise include the genesis of digital data and metadata, data management systems and their use, digital archiving and sustainability, and digital curation. Peter has led several important projects regarding research data in the humanities and has had several mandates from museums and institutions for digital projects. And he is, of course, author and co-author of numerous publications. I think we are now looking forward to your talk. And after the keynote and discussion, you're all warmly invited to join us for an aperitivo here in the courtyard of this building. And I wish you all a nice evening. Thank you.
So many thanks for the introduction. There are some details which I must correct and will correct. We are like a heading team. So Vera Chiquet, Lukas Rosenthaler, and myself, we are like trying to also be interdisciplinary on this level, which is quite not standard for a university environment. But I think it's exactly where we come from and what we try to do. So data science. The reason why we chose this topic is because we believe that it shows very nicely this evolution also of the DHCH events. We focused on the first year on images and the importance of text, namely metadata, which is an extremely strong and important part of image data. And in the last year, we were talking about methodologies in digital humanities, and time is not standing still. And so we really need to somehow focus on data science and what it all means. And I just try to give you my vision or my view to this topic, because I think it's really extremely broad and also extremely old if we think about what we do with data. And so if we first look at data, then it's quite something which is yeah, more or less undefined. It just means that we try to document something, we try to do measurements and actually store them and collect them to do something with this information which we achieved. It's absolutely not necessary that data is digital. We can have temperatures or humidity in the room, just anything, and that's data, but it's not digital. Digital means that we need an additional process to generate digital data, and we will briefly go into that. And this digital thing which happens means actually that we generate the code of those measurements so that we can process them, for example, with computer technology. And the code is something which means that we do not have an infinite number or values which are possible. No, we have a clear set of characters or values which we use to actually describe the data. That's the big difference. And so if we look at an image, and if we look at an image which we see with our eyes, which is kind of analog, but if we would look closely to our retina, we see that it is not really analog and not infinite in regards to resolution. But usually we say that's something which we experience and that's something which is real and analog. If we now want to generate digital data out of that, we need first a measurement device. That's usually a silicon sensor, which is called a CMOS or a CCD chip. And this sensor has pixels, single elements, which measure the value of light, which is actually approaching to this specific location. And then, and that's quite interesting, we get an absolutely analog data value, an absolutely analog value of the incoming amount of light, which is surprisingly very linear to the amount of light. So a very simple process, let's say, like that. And in the next step, what we do is actually we create a code out of this value. We usually use an analog to digital converter for that. There are plenty of manufacturers which create something like this. And this device, this analog to digital converter, actually delivers us a value, and this value represents this measurement, this thing which we documented in reality. The first thing in this image, the sampling rate, is actually the resolution of the image, the spatial resolution, and the digital value, which we see, excuse me, in this example, is actually the quantization depth, which means that we take each and every single measurement point, for example, one of those blue squares, and then the blue square is processed with this image. In the image, it's the opposite, digital to analog converter, but that's a detail. We have this electronic device which actually creates this digital value out of this measurement, and the digital value, we call this process quantization. So it's important to see that this data by itself is not meaningful, or it doesn't have a value in the sense of that it has a deeper meaning. These are just measurements. Anything else which we are making out of this data must be made from us or an algorithm, which today might be something which is in the context of artificial intelligence to be looked at. But it is important to see that data is these are just values usually. Anything else means structure it, filter it, process it, and that's something which we humans usually do. And so the question of today's talk is, how can we actually collect and analyze data so that we really can have a meaningful conclusion out of it? Because we store so much data, we preserve so much information, but we will see in one of the later slides, even the internet and the index of the indexing process of the internet is so not at the end, that we have such a huge amount of data which we preserve, which needs energy, that it is really worth to think about trying to take as much of meaningful contextualized information out of this information, so that we can really bring sense into the data we generate. So I want to give you an example what this could mean. I just actually in the night I was kind of not really deeply sleeping, and I remembered one thing which I think impressed me quite much, because it was something which a person, actually Fourier, realized just by looking at something which he thought it's quite interesting, and the impact of what he realized is so strong that we have it in our daily lives, all surrounding us. So Fourier, you see, it's quite already a long time ago, so it's not really the time we speak about digital information and computer systems, but actually Jean-Baptiste Joseph Fourier, he was working in many different fields. He was also in the team which tried to actually analyze the code on the Rosetta Stone. He was part of the expedition of Napoleon. And he was a physicist also, and he actually did an observation in the context of the flow of heat between two different molecules with a certain difference of temperature. And the result of this observation, also doing a protocol of these data measurements, was that he realized that each and every periodic function, an analog value, can be represented by adding up different sine and cosine waves, so that you can really make like a transition from the spatial values to something in a frequency domain. And that's an extremely powerful thing, which is, for example, being applied in data compression, JPEG, MP3, in noise cancelling. We have it in our watches if there is something like a heart rate monitoring, and so on. And to give you an example what it means, we have the spatial domain here on this side on the right. You see the sine curves. And these sine curves, if you combine them, you can recreate actually each and every periodic function in time. And you can do also the opposite. The opposite means that we can take any spatial function and we can transfer it to the frequency domain and actually analyze which components have been used, or which components do you need to recreate exactly this periodic function. And that's something which is quite interesting, because the periodic functions, we have them in many different things which we use daily. For example, in images. We can do this analyze process not only in the dimension of time, we can also do this in a two-dimensional space. And if you do this smart, you can actually generate an image of frequencies, and this image of frequencies can be like sorted as you see it on the left, where we have on the top left, we have low frequencies, on the bottom right, we have high frequencies. And if we do it smart and analyze now how human beings see an image, then we can actually say, very small and higher frequencies can be neglected because they are not relevant for what we see. So you see, if we measure something, so if we protocol information and data in value, and we have actually the technical skills to do that process, and we know about Fourier transforms, and we know about the human visual system, we are actually able to process and work with data in such a way that we can really do fantastic things, like reducing the amount of data about 100 times easily. By the way, you see down here the two representations. In the left, you see the spatial image of this black and white photograph, and on the right, you see the frequency image of exactly that visualization. So the problem, and that's just one of the drawbacks of JPEG, exactly this process is being done in a block size of 8 by 8 pixels. So each pixel block of 8 by 8 such small pixel elements, is being analyzed for its frequencies, and high frequencies, which are not of that big relevance, are actually deleted. We do not preserve that information. And the problem is, if we now take one 8x8 block and another one, we do not get the same amount of erased information. And that's why we see this square sub-pixel structure, which we call an artifact. So the image is not the same before and after compression, but that's something which was for the reason why this compression type was invented. It was actually not for the web or the internet, it was for video text. This was not that important, but in principle, it shows that we can have a very, let's say, strong impact in something which we do with data, which really can influence the way we work with data. Another thing which is quite interesting, and I just did a little bit of research about the things surrounding us, is the advance of technology. It's crazy how fast this happens. And if we look, for example, to something which I remember back in the 1990s, I had an IBM PC from my friend, which I were able to work with, and everybody spoke about Seymour Cray and the Cray one. It was more kind of a furniture. It's this thing on the right. That's actually a computer. It created also heat. So it was like in an old farming house, those wood stoves where you can also sit on a bench. It's the same there. It's furniture, heating element, and a computer. And it's quite interesting to compare that with today's technology. On the left, you see Konrad Zuse's Z1, which was obviously super slow. You see actually the mechanical and electronic components in there, but actually the right one looks pretty fast. It has a quite decent design, which means I'm strong. So the power of this Cray one was 130 megaflops. It means it can do 130 million floating point operations per second, which sounds also quite cool. If we now look at today's iPhones, which I think everybody of us has a smartphone in its pocket, I assume. Who has no smartphone here? Is there someone? Probably not. So everybody has one. So if we look at such a smartphone, and compare it with other computers like the Next, it was also a very powerful machine, very expensive. I believe if you have one today, you can sell it for quite money. The IBM XT, one of the earliest personal computers, and the iPhone, the first release. If we look at the power of this and the new Apple chips, the M1 Pro and the M1 Max, we have 5.2 billion such flops, floating point operations. It means much, much more than such a mainframe, large supercomputer of the 70s. So it means our infrastructure, which we have in our pocket, is able to do crazy stuff, which I assume is not really used up to date because of the lack of software, and I believe because of the lack of meaningful applications. So here's some numbers about also the penetration of those devices into our society. The Next computer has been sold about 50,000 times. The IBM PCs were sold in the best times 40,000 times per month. And if we look at the year 2022, 232 million iPhones have been sold, 61 million iPads, 26 million Macs and MacBooks. So 230 million supercomputers are out there and in our pocket. That's crazy. That's crazy. So another very, very impressive thing which happened in the last 40, 50 years is the internet, which is surrounding us also. It's the most penetrating network which we have. And the internet also is not that old. And if we look a little bit into its history, it was first called ARPANET in the 1960s. It was actually created for also for military purposes to have a shut-downable network, which has its own intelligence. Then in 71, the first email has been sent. 83, TCP/IP has been standardized, a very old standard, still working. It didn't really change fundamentally. Then 89, Tim Berners-Lee invented the World Wide Web, actually a service which is running on the internet. That's only a subclass of internet technologies, the web. Then in the 1990s, the usage exploded. Millions of computers have been connected to the network. And in 2000, social networking and mobile internet became mainstream. So if we look at the internet today, there are about 5 billion internet users worldwide. As of July 2022, 63% of the global population has access to the internet. The internet users in Europe are expected to be about close to 85% in 2025. And side statistics of August 2022 reveal there are nearly 2 billion websites on the web. So we have supercomputers in our pocket. We have a worldwide network of data sources and processing power. And so the question is, what do we do now with that? So that's also something which I found. Eric Schmidt, the CEO of Google, said that their actually indexing system of the Google search engine only indexed roughly 200 terabytes. And look at how small this is, 0.004% of the data you can find in a Google search engine. That's kind of nothing, which represents or which shows how big it is, what is out there, and how complicated it is to really acquire that data, at least with some kind of meta information. So computer and communication technologies really have created something which has never been there. I believe it's really the biggest revolution in human mankind. And so we have the potential to process, to disseminate, to access and process data. And again, the question is, what do we do now with that? So another thing which recently happened is that data must be open. Since a couple of years in Switzerland, if you do a national funded project, you must guarantee that your data is somewhere open and interoperable. And if you look at research data, I think, that's my personal opinion, you do not really see the impact of interoperability in research. If I look at this, that's fantastic. This is Google Maps, and I just placed there a route from Nusshof, that's a small village in Basel on the countryside, close to Basel, to Montefalco. Montefalco, I know from the Sagrantino di Montefalco, which is a fantastic red wine. And so I asked Google Map, how do I travel from this Nusshof, this small village, to Montefalco? And what we get as a result is the demonstration and the perfect demonstration of what interoperability means. Because all those public transportation companies offer their data in a standardized way. And what Google is doing is actually nothing else than just collecting this data and create something new out of it. And that's, I think, in two reasons, extremely nice. Because for me as a user, I have an extremely big added value, and it works, it's correct. And for everybody who is not, which operates a public transportation company and is not participating in that one and not opening up its data, you are invisible. So you have a strong force to be part of that community. And I think we should have such showcases also in research and especially in digital humanities to not only say it's important that we have fair data and we need to be operable. We need to show showcases. We need to show and demonstrate what we can do out of that. The same Amazon. It's super easy to make your own store on Amazon. You can actually read the documentation of the API for selling partners. It's not very expensive. You see, as an individual, about €1, I think it's per month, and no, per item sold. And you see, you have a very good documentation, and you can actually really use this platform to sell your stuff. And that's also has a big impact. And it's exactly what we are talking about. I think we spoke last year about APIs, what it means, how important it is, but I think we need showcases. We need the demonstration of exactly this impact. So data must be analyzed. That's like the next step. And there are different ways we can do statistics and bar graphs and show how such, let's say, data can be transformed into something which is visual. And we can even do kind of animations. I think that's a video which I probably can start like that. That's just a nice way how information can be presented from the New York City subway system. You see that's the network, and then you see weekend riders, which lines are very often used and which others are not very often used. You can animate it, and you can make this data attractive to just perceive it in a way so that it is kind of, leads you to new observations, or maybe it's just something which looks good, let's say like that. So the question is also, how can we process this huge amount of data? And this huge amount of data actually profits enormous from artificial intelligence. And artificial intelligence, in its broader sense, is something which is very old also. It's something which we have in statistics. I mean, a linear regression is actually also artificial intelligence, because we extrapolate something which we do not know. So it's a prediction of a value. But to be more precise, what we are talking today is either machine learning, where we need a lot of manual feature extractions, or we speak about deep learning, where we even try to find out what part of data is actually interesting to get good results. And what it's interesting that this field of artificial intelligence is really something which I believe happened very strongly in the background, so that we didn't really realize what is going on there. And now it somehow comes to the surface, and we immediately see how much money and resources have been put into creating those systems, namely OpenAI, for example. I don't know how much money has been invested in there, but they did a lot of work in the recent years. And now we speak about ChatGPT, ChatGPT-4, and so on. But what is interesting, that you have nice tools like this one here. That's also a small video. That's a tool where you can actually type in stuff. It's based also on machine learning approaches, show the relation of Bitcoin and gold price in history. And then you actually, the system acquires all your data. It's compared. It's actually shown in a way so that we do not even have to understand something from the technology. Another example which I would like to show you is this one here. It's from Adobe Firefly. It's crazy. It's just in this update. So we do also kind of inpainting, the yellow lines. We extend the image with stuff which wasn't there. Or in this example, we create a new background. That's built in Photoshop. So it's not something which is research. It's just public. So it's just there in programs. So crazy, I think. I never used it. I actually just by accident saw that this is possible and that it's implemented in in Adobe. And what I really think it's interesting to see that the way we work with those systems is always this slot, and it's not a searching slot anymore. It's a chat slot. We talk with those systems and we explain what we need. And I think that's really something quite interesting. So what is next? So we have a lot of technology. We have the supercomputer in our pocket. We have the internet. We have a lot of data. And so we have tools which can analyze the data. And now what do we do with that? So I think we have to see that we need to react, because the technology will develop. It doesn't really matter what we do. It's something which I think it's such a huge industry that the technology will get faster, cheaper, bigger, algorithms will be more efficient, the amount of data will grow, and actually I think artificial intelligence or machine learning, deep learning are really just at its dawn. And what it really lacks, I think, are meaningful research questions from the domain of humanities. Actually, I think the core business of people which come from the humanities. And what is very interesting to see there, we did seminars with our students in exactly this field, where we were just asking the simple question, in what are things you are interested in? You have everything. You have technology, you have software, you have data. What are you interested in? What is a question you could ask this digital world? What are patterns? And I like the word pattern very much. It's I also recommend this book of Nasehi about pattern, because I think we create patterns, and that's exactly what such systems are optimized for. You can search for them. We can correlate data. We can explain, prove, question, compare. And I think we should use this to really create new research topics and create innovation based on that. And I think, that's my personal opinion, that the technology domain needs the humanities domain much more than the opposite way, because the technology will follow us anyway if we have the interesting applications. And I think the awareness of our history and the awareness of cultural development is extremely important to make meaningful technology. All that, it's fantastic, and there is also a downside, which also just recently happened, and I have not been aware how strong this growth is. We had a lecture of an invited person from the state police. He is like a detective for cybercrime, and it was crazy to hear what this person said. I mean, it's really something which is growing. Cybercrime is really growing, and what we actually do is we create a perfect environment to allow people to do what they want to do. We have homogenized systems, we have standardized interfaces, we have standardized APIs, we have standardized data. And this means that it is very simple for automatically activated, let's say, bad software components to actually work with this big network of the internet. I mean, I don't think there is not a lot in our society which is not relying on the internet, electricity, water. I'm not sure what happens if we do not have this network. And it works, so you can really do bad stuff. And just recently in Basel, they hitchhiked 1.4 terabyte from our Department for Education. It's in the web. If you are interested in psychological reports of our students, you can read them there. I don't know how interesting it is, but it happened. And actually, this happened 1 month ago, and I just recently drove in the car, actually 3 days ago, and it happened also that actually the federal police has been hacked, and they placed 0.9 terabyte of information about police things. I don't know what exactly it is. I didn't look at it. But actually, the person which is the media representative from this department had a very shallow voice when he tried to explain in the radio what happened there. It's crazy. So I think besides all those dynamic developments of data networks, infrastructures, I think it is also worth to think a little bit in another direction, which doesn't mean we shouldn't do data sciences, but probably we should also preserve the stuff which we are sure that it is authentic, which might come from our history. And so I believe that there is a need for offline preservation. And 2 months ago, I would have said, well, probably not, but somehow I believe, yes, it's important. And what does it mean? It means we have today not really storage systems which are focused to be offline. We have living archives, which is very important. We have S3 storage from Amazon, which is scalable, which has automatic redundancy, which is really fantastic, and we need that. But I think we also need the other thing, and it's like crazy how it circles back actually to 2007 when we did this project actually with Ilford, this film company which had a production site in close to Lausanne, in Fribourg actually. And what we did in this project was to do the same as you do usually with QR codes, just on a very much smaller scale. So take the bitstream of a file and take the zeros, make a black dot, take the 1, make a white dot, and just do it on microfilm. That's a microfiche, which you see on the right, which is 10 by 15 centimeters, if I remember right. And then you can put their handwritten, also human readable metadata. You have those square elements, which you actually can preserve the bit stream. And if you do it smart, you even can actually create the code as a pseudocode on such a data carrier, which explains you how to reconstruct those bit streams. Actually, we didn't really follow the project for years. We had collaborations with a guy from Norway, Rune. I don't know, maybe you know him. He created then a European project which was called Pickle, and out of Pickle, he created the Arctic World Archive, which is also fantastic because it took such a long time to do that. But I think he really now is in the right spot and the right time. And the Arctic World Archive is really, kind of like in a science fiction movie, even though it goes really back to fundamental things like being not online, take film, because film you cannot modify very good without it is detectable. And I just want to show you a short video of this Arctic World Archive. It's like in a James Bond movie.
Deep in the Arctic Circle, an archipelago covered in ice, Svalbard, home to the northernmost town in the world, to thousands of polar bears. And it is here you can find the global seed vault. Millions of seeds have been sent here from across the globe for secure long-term storage in cold and dry rock vaults. Just down the road is a decommissioned coal mine that has taken on new life. This is where we will protect open source software for future generations. Deep within the permafrost layer, which can stretch up to 400 meters thick, we will store the world's open source software on silver halide film. The data is encoded on frames with 8.8 million pixels each and designed to last over 1,000 years. In our initial deposit, we archive thousands of the world's most depended on open source projects. The work of hundreds of thousands of developers from around the world. We will return next spring during the perpetual light of the midnight sun. To deposit every active public repository on GitHub. For safekeeping in the GitHub Arctic Code Vault.
So it's kind of a part of this Arctic World Archive. And yeah, with this, I come nearly to the end of my presentation. But what is quite interesting and something I read, and I think for me it is very true, is this one here, because this guy for cybersecurity and how we work with all this gigantic stuff, also with the speed of our mobile phones, with the internet and all these things, is very dangerous. And I have a password manager, which is actually stupid, he said. I had an admin account as a standard account on my MacBook, which is very stupid, he said. I changed it now. I use face detection with my mobile phone because I do not remember all the passwords and I shouldn't have only one, so it's complicated. And finally, I'm lazy. And that's why actually I potentially deliver everything which people which are probably faster in working with data than in other domains can do nasty stuff. And so don't use your computer with an admin account, switch off face recognition, and don't use a password manager. Our federal security officer said, I shall tell this to you. And with this, I come to an end of my presentation. And if you have a question, you are welcome. Thank you.
So thank you very much. I'm here to coordinate the questions, also digitally. So feel free to just post your questions in the chat, and then I can ask them. Maybe I first want to open up the round in the room. One has a question. We have a mic.
Oh, I have it here. So thank you so much again, Peter, for the presentation. That was really illuminating. I had actually quite a punctual item that might spark a bit of a discussion. The application you showed earlier, I think it was called BitSave.
Yes.
It kind of reminded me of the way that graphics was being displayed on computers of the 80s, like the Commodore Amiga, to display more colors when you didn't have enough bits in your registers. They used like bit planes.
Yes.
They actually had hardware to manage parallel entire encodings of playing, say, black, white, then red, not red,
yes,
and so on. Could it be the case that, you know, the current phenomena and ways to encode and store and preserve things offline have to rely on systems and methodologies that predate actually the internet being online, simply because there was an ingenuity then that was not being marred by the fact that you had the comfort of storing things online.
Yeah, yeah.
Would you say that?
Yes, it's a very good question, and I don't know whether I can answer it well. I think there are several things which probably at the end do not really work with this offline storage. I mean, of course, the microfilm you can preserve for 1,000 years. The media carrier itself, you can actually certainly read what is written, human readable, and how to decode those barcode elements. But what I believe is that anyway, we have the problem that we need to migrate on a certain level. So things are just changing. And I mean, of course, if we have on a very basic level just images and text, then you could do it like that. But maybe then you can't just store an image and text on such a device, because technology will improve so much that you can easily do actually text encoding and OCR with what is on there. So I believe it's just for me, it was important to actually see this pickle process and this solution with the Arctic World Archive again, because I think it's a strong point to also keep in mind that we really have to be careful that we do not get too lazy and really support the big industries in what they actually want to get actually data from us. And so it's, yeah, there are small things. I don't know, names in WhatsApp, profile images. Actually, I really started to remove that all. The bad thing is you cannot really remove it. You didn't see the talk of Vera this afternoon. She actually visited the archive.org, the Wayback Machine, and that's nasty. All that stuff is still there. But I think from just the mindset, I really think we also have to bring in the humanities aspect also in this sense, that if we speak about cultural heritage, we actually have to de-accelerate somehow a little bit, or create new stuff which has a little bit a trend against what happens from the big companies. I think that's very important that we do that.
I think that too, just a close thing, just like in order to preserve digital content, we kind of go back to the old ways. So something like bit planes,
yes,
for images and what have you. I agree that it is an opportunity for us to investigate,
yes,
how on the evolution or involution, if you will, of methodological aspects of this.
No, you need specific machines if you want to read back such a tape. I mean, we still have the problem. I mean, it's not a big difference to a hard drive finally. So, but from the idea, I think it's interesting. But I agree with you absolutely.
Yeah, you partly answered a little bit of it, but my problem is maybe a bit iconoclastic. I don't know, but why do we have this urge to try to preserve everything? If it would be like that, we'd be still living in wooden huts or in caves. So
yeah,
of course, I like to visit this temple in Rubens, but
yeah.
we shouldn't keep them all. So now it's like we are afraid to throw things away and to destroy things.
I think I mean, I would like to cite Aleida Assmann. If you want to remember, you need to learn how to forget. And that's absolutely correct. And I think because it's too easy, it's so comfortable. I do not have to delete images on my mobile phone. If the next generation will have 2 terabytes, doesn't matter. And so I'm not forced to do it. And if I remember my mother creating photo albums, I mean, they had 36 images on a film. And most of them were not sharp or wrongly exposed. So you just had an automatic process of selection. And this we don't have anymore. I mean, actually, it doesn't even matter how bad my skills are in photography. My mobile phone makes a good image. And the storage is there. I do not need to delete it. So I think it has really something to do with this comfort factor. I'm not forced to do it. I believe, as in my case, this is true.
Thank you very much for the presentation. And I have a question about these big tech companies you mentioned, because like Amazon Web Service, for example, or you showed as well with GitHub on the microfilm.
Yes.
It's part of Microsoft. So, and as well like Meta with all the data, Instagram, etc. ChatGPT, we don't know what's behind. They're like big tech companies behind, and we have no clue what's in this data. So they're not really fair. And they have as well a huge budgets for persons and projects as we would never have at university or to research. How can we compare with them? Or do we even have to?
I think we cannot. I believe it's not possible. You remember the visit at the European Space Association last year, where the head of the PhilLab said that there is one major problem. They do not have access to so much computational power as the big companies. They cannot. It would be possible then, but then you have to pay for it. So there is not one university, he said, in the world which has so strong computational power as, for example, Amazon. And that's a problem, because all the things which we do now with data science, and especially deep learning approaches, they need a lot of data. They need a lot of processing power. And I think it probably would need something, and that's actually a good idea. At the Christian, which you have, it would need something like a network of power and aims to collaborate together. I mean, there is this nice project SETI, Search for Extraterrestrial Life. So you can switch on your computer and you offer your processing power for something meaningful. I mean, that would be quite interesting to do that in digital humanities. But we need the question. We need the question. I don't know. I hope so. Yeah. Yes.
Thank you, and thank you, Peter. I want to slightly circle back to the question of my friend Eric here, which was about what to discard, but we could also ask what to prioritize.
Yeah.
And one of the downsides that I didn't see in your slides was the ethical implications of the digital divide, and whether we see it as a trend that this divide will only increase, or I don't know if we are anywhere near looping back to a more equalized situation. But do you think that we as digital humanities and digital cultural heritage professionals can somehow also help mitigate here what is happening with these big companies who own the big data?
Yes, I absolutely believe so. Because it's again, I mean, we are the people which understand this domain. And I think the people which create such machine learning approaches, they do not even care about bias. So these are specialist groups which create algorithms, neural network systems, and they are probably, I believe so, completely separated from the people which take care on data, so on storage and APIs and stuff like this. So I think what the big challenge or what the big chance for digital humanities or people which do technology and cultural heritage things in the digital domain is that we really have a true interdisciplinary approach. And I really think that we have, that's a chance which we have, which I believe the big companies do not have. Of course, they try to, I mean, with Google Arts and Culture Lab, for example, but that's definitely not their core business. So I think, yes, I think we can create awareness, and that's very important, because the big companies just survive because of the people, of the customers. And if they change their mind, this has strong impact to the companies. Yeah.
Thank you, Peter, and thank you for the conversation. I'm feeling that there is a basic difference between generating data in the science, in the hard science, in geography, in many application areas, and generating data in cultural heritage. Because the generation of data in cultural heritage implies the participation of human beings. So it is slower, the pace. And there is a reflection of what we are doing. It is more expensive. And therefore maybe less rewarding economically. And this dichotomy that exists since ever between science and humanities seems to become even more impacting in the digital world. Does it mean that there is a chance for the digital heritage to become more precious, to become more important, to be able to reflect on something that is accelerating, generating a lot of data without understanding? So is there a possibility in this sense, in your opinion?
I hope so, and probably yes, because I think also it has to do with awareness. And I think for me, I mean, I'm not the person which is visiting a lot of museums. I mean, of course I do, but it's not one of the main things I do in my spare time. But I think still I'm a person which has just in our society, if you have, for example, children, you have a responsibility to take care on the things you are creating, which you are doing, and also I think a responsibility for the way how we work with digital environments. And therefore, I believe that if we can also demonstrate and show how we can work with cultural heritage in the digital domain, if we have showcases in the web, if there is a presence on social media channels, I think this has a very strong impact. Just for example, to make people be aware of the importance of images. Not just maybe for themselves, but also just to do this selection and to preserve it in a way which is interesting for the next generation. I think that's I think that's very important, and I think there we have a big chance. Also, I also see there is a huge gap for example, in the city of our university between the museums and the researchers. The researchers really say that museums do not have research data, and that's wrong. That it is research data in the humanities, not in the natural sciences. And I think to show really what you can do with those things, to create innovation out of things which are old, let's say like that I think that's a fantastic chance which we have in this field, and we need to try, I think. Yes.
Good evening, and thank you for your presentation. Beforehand, you were answering to another question, and you spoke about like sharing a network for
Yes.
computational power.
Yes.
So I was thinking, in the last few years, we are talking and listening a lot about blockchains.
Yes.
Do you think that sharing computational power and validating data through blockchain might be the future, or something that it will be useful as they tell us
Yes.
now, or there are some downsides to it?
It's the only thing which I think it's interesting. I mean, the microfilm stuff, what is really fantastic about this analog film is really that you cannot that easily change the information which is on it. It has kind of built-in or authenticity. And I think it is with blockchains, I could imagine that it is really a chance to preserve like metadata about the data we have, to really demonstrate that it has not been changed. And I think that's something which also might become more and more important in the future, because it's yeah, I mean, I really was impressed with what, for example, is possible with Photoshop. You don't even need to be an expert. You just can create something which probably will be in 1-2 years probably very hard to distinguish whether it was real or not. And so I could imagine that for hashes, it could be quite interesting to work with blockchain. Yes.
If there aren't any more questions, I maybe round up with a little thoughts of mine, because I was like kind of a bit depressed when you started with the cyber crime and so on. And I thought, oh, standardization is so important. And then you say, no, it's a bad idea. And also that we're not, I mean, we cannot compete with these like big companies, but I think we don't have to. So that's not our goal, right? But I think it's very important to not just leave the field for them, but also engage in it and do stuff with it, and criticize or be creative with it, so that we can actually make their kind of a difference, and not just say, oh, we have no chance. So I think now I'm kind of optimistic again, thanks to your roundup at the end. So I'm looking forward to these other discussions we will have tomorrow and after tomorrow. And I think we kind of can continue our discussion in the apero here on site. Thanks for listening also digitally and remotely. And for those who stay here tomorrow, we said that we will have a short stand-up at 10 minutes before 9 in the atrium for those who are a bit confused and don't know where to go, so that we can like go through the program again. So thank you very much.
Thank you.